Good morning, everyone. This is Tom Wolniewicz, VP of Business Analytics from Broadstreet Data. We will just about to get started with our webinar today, and I'd like to welcome everyone and thank you for joining us this morning. And today we'll be talking about predictive analytics from SAP, the analysis tool that allows you to answer questions such as what could happen, what might happen based on doing statistical analysis and mathematical modeling of your data. Anyway, without further delay, we'll get started with our webinar today. And just as a side note, we will have a Q&A session at the end where we will answer any questions you might have. So please enter them in the chat, and Allison will read them back afterwards, and I will be happy to answer. Or you can email them to either myself or to Allison afterwards as well. So once again, thank you again for joining us, and we will get started with our presentation. Just to give you a high-level agenda of what the presentation will consist of, we will do a brief introduction. Then it will be followed by the high-level overview of what predictive analysis is and what the capabilities are of predictive analysis. Further, we'll get into a lot more detail of the SAP BusinessObjects Predictive Analysis product suite, and we'll take a look at the data loading capability, the data preparation, processing, visualization, and sharing of your analyzed information. We'll also take a look at see how predictive analytics can integrate with SAP HANA and leverage the in-memory capability of SAP HANA. And then we will conclude our presentation and have our Q&A session. Okay, so just to give you a high-level overview of my background, once again, my name is Tom Wolniewicz. I have over 12.5 years of business intelligence and data warehousing experience. I've been working within this field quite extensively, over 6 years, working with Business Objects Professional Services, as well as for the last 2.5 years with Broadstreet Data. I'm a member of the expert panel at analytics.org, and we'll briefly touch upon that as well in this presentation. I've led many different implementations of BI, mobile BI, Explorer solutions, and architected and designed and administered very large BI implementations, some even in excess of 6,000 users. All right, so in terms of SAP and your data analysis limitations that you have today, what if you could identify some of these opportunities within your business, within your data, within being able to take and leverage that to make better decisions and identify revenue opportunities? This is what predictive analysis can help you gain that level of understanding in your data that you previously didn't have. It does require a high degree of statistical and analysis knowledge and understanding of what these algorithms can do, but you can gain immense amount of value in things like identifying high-value customers and increasing cross-sales and identifying opportunities and building long-term relationship with your customers, with your employees and partners. So basically, by taking in any of the data that you have, you can further analyze it, and you can further gain a competitive advantage from this data that you otherwise wouldn't be able to ascertain in a very traditional BI sense. Okay, so we'll get into more of a high-level overview of predictive analysis. Traditionally, what BI enables you to do, and this is another diagram that highlights this, is analyze and see what exactly happened in your data. So what happened? What transactions occurred? What customers bought? What information you've collected? You can analyze that in traditional BI sense. Then, in a more generic predictive analysis level, you can get into the state of identifying why did that happen. Now, some of the existing BI, traditional BI capability does enable that, but it involves a lot of work, a lot of custom development, a lot of very advanced report building, and applying these concepts in a very, very manual and tedious way. So with predictive analysis, we can take that even to a step further and get into even more mature BI by looking at predictive modeling in terms of answering questions like what will happen, and also looking at optimization and trying to determine what is the best possible outcome, and coming up with different mathematical models that we can then implement these various scenarios and find out what is the optimal scenario, what is the best possible outcome, and what can lead to that. So by doing these types of scenarios, we can leverage our information that we already have to optimize our business processes, our business functions, and determine what is the best possible outcome. Okay, and if you take a look at some of these quotes from the first one from the Gardner Group, it really highlights that the pinnacle of BI in terms of the maturity is the analysis of large amounts of information and recognizing patterns using statistical and mathematical techniques. So it is the highest level of BI maturity if you look at it from the standpoint of the Data Warehouse Institute in terms of their BI maturity model, in terms of taking BI to the next level. And similarly from the Data Mining Techniques book by Gordon Linhoff and Michael Berry, we also see that the exploration and analysis of large quantities of data in order to discover meaningful patterns and rules. Again, patterns in your data is the keywords here. And identifying those. It's typically very difficult to do with traditional BI, which focuses more on your operational data as well as your KPIs and things like that that you gain from dashboarding and traditional BI. So by identifying these patterns that occur in our information, we do more of statistical type of analysis that we can do with predictive analysis tools. So some of the challenges that predictive analysis focuses on, and I've identified 5 here that it's very good and capable of addressing. And we'll start down the list of the first item, which is forecasting. And that simply looks at taking our historical data into consideration and various performance metrics and translating them into future performance. So what is the likelihood of a particular forecast based on a high level of probability occurring in the near future? So we can actually model that quite accurately using advanced mathematical models. Similarly, we can also see what the key influencers are within our data. What are some of the key customers, your key employees? What are some of the key data elements that actually impact various aspects of your data? Furthermore, we can identify trends. So what are some of the historical trends, as well as what are the emerging sudden changes, unusual values, and how do those impact the actual short-term trends, long-term trends, and historical trends? We can also identify relationships between our data. This is a very key benefit of this type of tool, is that we can see the correlation between not only the values, but also the different types of data elements that can help us in better understanding what is the relationship of one data element to another. And last but not least, identify the anomalies that exist within our data, and to see whether they actually have an impact. Are they an indication of a change of trend, or are they just random data elements that just are scattered throughout, that happen randomly and are just anomalies that can be ignored, or they are things that we can focus on that actually can create a breakout situation or can change our trends and affect our business in the future. So identifying those as early as possible can be very, very meaningful to your business. Okay, next we're going to dive more deeply into the SAP BusinessObjects Predictive Analysis tool and see what its capabilities are in more detail, and see what the tool, how it looks like and what it can do, and what are some of the key features of it. So the SAP BusinessObjects Predictive Analysis tool consists of two key functions. You can intuitively design complex predictive models. So that is our first function of the tool, where you can actually read the data, you can manipulate the data, you can apply various algorithms to the data to model those types of complex scenarios. And then further, we can then visualize and discover these and display our data all within the same tool. So the key benefit here is that we don't have to go to another tool. We can if we want to, but we can stay within a single analytical environment where we can model and analyze our data all at the same time. So we can easily change and go back and adjust our model to see how different scenarios play out. Okay, so just to get into more detail about the designing of these predictive complex models. So for that, we can actually read the data from many different sources, and we'll get into that in more detail. And these sources include relational databases, flat files, even business objects universes that we can directly integrate with, and even SAP HANA, which we have native connectivity to. And furthermore, we have the ability to, just with a visual drag-and-drop interface, create data selection, preparation, and processing components in our data flow. So we can actually model these scenarios in a very user-friendly way, and we can see how this model impacts our data as well. And then on the visualization and analysis point, we can analyze the data in a very graphical way, in a very statistical way, so we can model it and visualize it. And then further on, we can actually share it with other BI tools. So we can actually export the data back into our relational database. We can export it back into SAP HANA, and then actually use traditional BI client tools like your Web Intelligence, Explorer, Crystal, even Excelsius to connect to our analyzed data and build and models that we've already created, and perform more ad hoc type analysis with that data. All right, so now we're going to take a look at the 4 steps, which are basically our life cycle of predictive analysis. Step 1 in this particular case is loading of the data. So we can load the data, like I mentioned before, from a text file, from a relational database, from a universe, or even from SAP HANA, and we can then use that to analyze our information. We can also load data from multiple sources, merge it within our predictive analysis model, so that we can actually load and analyze information from many, many different sources at the same time. Then the next step is to prepare our data, and we'll get into all of these in more detail as well. So you may want to apply some filtering, apply some merging of the data, any kind of transformation functions before you actually do the analysis on that data. Then the next step 3, is the actual processing of the data. This is where we take and apply the mathematical analytical functions that we can actually process and analyze the data. We can determine what the clustering is, classification, association, time series, and many, many different types of data processing algorithms that are out of the box, as well as can be integrated with the tool. And then finally, we can take our data, visualize it, as well as share it with BI tools, or visualize it and analyze it natively within the predictive analysis client. Okay, so going into more detail about the first step. So like I mentioned earlier, we can use anything ranging from a Excel, CSV text file. As a data source, we can connect to any relational database that's an OLAP or a ODBC connection, including OLAP cubes. And we can also connect to business objects universes. Now, in this particular release, we are limited to only connecting to and using UNV files from both version 3.1 and 4.0. In the future, UNX or multi-source universes will be available as well, but currently we only have the ability to connect to UNV files and load the data from UNV files, from the universes into our predictive analysis tool. We talked a little bit earlier about the data preparation, and actually this step in some cases may be optional, in some cases it may be required. So when you want to merge data from different sources, you need to prepare your data, or if you want to filter it or apply any kind of function on it and group it in different ways, this is where you need to prepare your data. Typically, if you're using a universe or a relational database, you can do that at the database level to speed up your performance and get the data already in a format that is useful to you. In this particular case, we do have the capability of using some of the basic ETL capability to prepare our information and transform it in a way that becomes more useful for the analysis phase. Now when we get into more detail of the actual analysis and processing of the data, so once you've actually prepared the data, you can apply the various algorithms that are available to us. And we have several various different algorithms. It's a long list that we'll get into more detail of what they are. And here is the first set of that list. We can do anything from performing time-based predictions using time series algorithms to using regression algorithms for predicting continuous variables based on other variables in the data set. We can also use association algorithms as well as clustering algorithms to group data into various groups using algorithms such as the k-means algorithm. And then the next set of algorithms that are all available out of the box are classification algorithms or decision tree algorithms, outlier detection, as well as neural network algorithms. Again, these are all available to us to use out of the box. Furthermore, we can actually integrate and develop our own models and our own algorithms using open source R tool, which can directly integrate with SAP BusinessObjects Predictive Analysis and apply those R statistical algorithms and modeling on our data as well in our data flow. Then finally, we have the actual data visualization and sharing capabilities. So after we've analyzed our data, after we build our statistical model, we can analyze our data visually as well as in a tabular format, as well as export it back and write it back to a text file in Excel spreadsheet or a relational database, or even writing it back to SAP HANA. Now, in terms of the data visualizations that are available based on the different algorithms that you apply, basically here's a table that supplies a list of compatible visualizations that are compatible with certain types of algorithms that are being applied to your data sets. So here is just a view of a tabular view, and basically I've applied a outliers detection algorithm to see if any of my data meets that particular criteria in this particular page. I don't see any, but there are some down the line. And here is my statistical scatter plot and distribution visualization, which actually showcases some of the distribution of my data to see where my data is distributed, and I can actually expand any of those and interact with these points to actually get more details and see what these elements actually are. So this is just off of a single data set. We actually even have the ability to do parallel coordinates visualizations as well. So we can see how data relates and how data is distributed in terms of the types of data that we've selected in terms of the various columns and ranges of that data, and where it is distributed in terms of the values. And here's an example of the actual ad hoc capability of the visualization. So we can actually even do ad hoc visualizations where we can pick the type of graph, we can pick the columns that we want to see of our analyzed data and apply any kind of filters we wanted to. So similar in the way you would build a Webby report, you can actually build an ad hoc visualization as well, right within the predictive analysis tool. Okay, so that mainly covers the capabilities of the tool using just your relational data or flat file data. Next, we're going to take a look at to see some of the features that are available to us when we actually use SAP HANA. So predictive analysis can integrate with SAP HANA. It has native HANA integration. So first, just to give you a high-level overview, what is SAP HANA? It's a pre-configured out-of-the-box database appliance from SAP. It is an in-memory appliance that bundles both the hardware and the software delivered by a SAP partner, such as HP, IBM, Cisco, Fujitsu, etc. It's an in-memory computing engine. What does that mean? That means that the data actually that you're interacting with, that you're querying, that you're analyzing, it is all in memory. It's not on disk, which means that the I/O performance is incredibly fast. And in terms of database performance, we have at least 2 orders of magnitudes faster performance. So in a traditional database, where you might see a query performance of about 10,000 rows per second, with SAP HANA, you will see with the same data approximately 1 million records per second being read. So the performance benefits are exponentially higher. We also have the ability to do real-time data integration with ERP systems, and basically we support various content packages like extractors, data modelers, and integration with data services and predictive analysis. I mentioned earlier Hanalytics. Hanalytics.org is an online community where we post a lot of white papers, where we post a lot of information about SAP HANA, and you're able to connect with local subject matter experts that can help you with any questions you might have. So I invite you to visit Hanalytics.org and scan through it when you have a chance. Okay, so by integrating predictive analytics with HANA, well, one of the key benefits is that we get the ability to do all of our modeling, all of our analysis of that data, all of the actual computation of these algorithms that are applied to our data, they will all occur in memory on the HANA appliance. So so we have full integration of the actual execution of our analysis. The design still happens on the predictive analysis client tool, but the actual execution of that predictive analysis happens on the HANA appliance. So it is lightning fast when it comes to analyzing large amounts of data. So like I was saying, we have the ability to natively execute these algorithms. We also have the ability to integrate with R, which is the integration tool, which is the statistical analysis tool. We'll get into that into more detail later. And that enables us to leverage some of the statistical modeling and statistical and optimization modeling of our data, and apply those statistical models directly within predictive analysis. It's actually being taken one step further, where those custom-built predictive models and statistical models are actually executed in memory on the HANA appliance, as well as the standard algorithms that are available to us. Now, some of the algorithms that are available for HANA are specifically tailored for HANA, but basically all of the algorithms that are available for non-HANA use as well. Okay, so what is R? R is an open source statistical modeling and optimization package. It's very widely used within academia, financial institutions, government, and industry. It is free, it's open source, and it's one of the largest implementations of statistical modeling and data mining that's available to us. However, integrating it with predictive analysis takes this to one step further, where we can actually use the integration to interact with data from universes, interact with data from HANA, and leverage that visualization capability that's available to us in our BI tools, as well as the predictive analysis tool sets as well. Okay, so here we see the actual overview of the HANA landscape. So in our HANA platform, we do have native predictive analysis libraries that are built into SAP HANA, as well as our integration for SAP HANA. So when we build our models, we can publish them to HANA, and then those are applied to our data when we actually execute the predictive analysis models. We also have the ability to integrate with other applications like BI clients. So after we've done our analysis, we can actually write back directly from predictive analysis back to HANA. Actually, the data will never leave HANA. It will just stay in memory after it's analyzed, and then we can write it back to another table. And we can also model our information using the SAP HANA Studio in terms of how the data structures are modeled that we're interacting with. And we can also obviously feed our data in from various sources like data services and integrators, Sybase integrators into HANA directly. So again, just to summarize, we can leverage the in-memory capability of HANA to be able to analyze our data in a very fast and effective way. We can run multiple scenarios and very complex models in memory to analyze large amounts of data and push this data processing to an in-memory server environment that can process millions of rows per second and analyze our data very, very effectively and visualize it in this particular workbench environment. Okay. So just to conclude our presentation, we will have a Q&A session afterwards, and I'll be happy to answer any questions you might have. So with all this in mind, just as a takeaway, doing traditional BI within your organization enables you to take your data to a state where you can make decisions based upon it. You can analyze historical information. But in order to take that data to the next level and anticipate behavior, empower your organization, and create very advanced models in order to decide what are the future likelihood outcomes of profitability, product releases, or even strategies of that are customer-centric, such as building marketing strategies to target specific customers. All that level of analytical analysis is based on statistical modeling of your data, and this particular tool set is very, very well suited and well positioned to take advantage of that particular function, and performs it quite well, and is able to extract a lot of value from your data that lies beneath just the numbers that are there in your traditional warehouse, BI platform, OLAP database, or SAP HANA implementation. So once again, thank you very much for joining us today. I would welcome any questions that anyone might have. Yeah, once again, thank you so much for attending this presentation.